Welcome back. This time I want to talk to you about difference of squares. Fancy name for something that happens a lot when we start factoring in math. Alright, we are going to factor x squared minus 36. And what that means to you is that we are going to use our area model and we're going to break it apart into two binomials. So remember how we do this from last year. We took our x squared and put it in the top left corner, and our constant term goes in the bottom right corner. And then we would take the x term and we would figure out a way to get it into these two boxes. Trouble is the x term is missing on this one. So remember the x games? We have to do this multiply to get these and add to get these. Well, that's what we're going to do. We are going to multiply to get the constant term, the negative 36, well, x squared. We're multiplying to get these, but we're going to add to get this middle term, which right now is 0. So this funny thing happens. If I need two numbers to add up to 0, I need them to cancel each other out when I add them together. Let's think about numbers that multiply to be 36. I could have a lot of choices here. I got 1 and 36. Well, those aren't going to cancel and be a 0, are they? I could have 2 and 18. Nope, those aren't going to cancel. 3 and 12. No, again. How about 4 and 9? No. How about 6 times 6? Wait a minute. Look at that. If I take positive 6 and negative 6 and I add them together, they will equal a 0. And so I just need them both to have an x with them. So I get 0x and I'm in business. So we're going to go put negative 6x and positive 6x in the two boxes. Alright, to get x squared, I'm going to multiply two things here. So I'm going to take x times x and get x squared. There's my area. X times what is going to be negative 6x? Well, negative 6. X times what is 6x? Positive 6. And does 6 times negative 6 equal negative 36? Heck yeah, it does. So here's what you just did. You rewrote x squared minus 36 as x plus 6 times x minus 6. Remember doing that last year in Math 2? Alright. These were called the x games or x box. Okay. And so we're going to do that again. I want to show you that one more time. 4x squared minus 9 is this polynomial, and we're going to go put it in a box. Now, we're also going to need our x. Okay, folks, I want you to pause it here and see if you can fill in everything, and then rejoin me when you think you've got it. Alright, 4x squared goes in the top left corner. Then constant negative 9 goes in the bottom right. I need to multiply to get negative 36x squared. And I need them to add to be, 0x, because that's going to cancel out. I got a 0 in between there. So what multiplies to give me negative 36x squared? Hey, we talked about this a second ago. 1 and 36, or 2 and 18, or 3 and 12. These are not adding up to 0, are they? 4 and 9, 6 and 6. Remember those? That's happening for us again. I did not mean to do that in two times in a row, but this one's different. To get 4x squared, I need to multiply 2x times 2x. Now, why did I choose 2x and 2x instead of 1 and 4? Well, because 2x is the GCF of this row, and 2x is the GCF of this column, and that's what's happening there. Okay? 2x times what is negative 6x? It's negative 3. And 2x times what is 6x? 3. So what we just did was we broke this down into two factors, 2x plus 3 and 2x minus 3. I want to pause here and talk about what is going on. You might notice that these two kind of have some similarities. I've got a something x squared minus a something. This is called difference of squares because this is a perfect square. X squared means x times x. And 36 is a perfect square because it's 6 times 6. If you can take the same number times itself and get that number, it's a perfect square. And so notice that my x and x ended up in there, and my 6 and 6 ended up in, and I got a positive and a negative. Very interesting. Let's try this one. 4x squared is a perfect square because it's 2x times 2x. See, we saw it over here, right? And 9 is a perfect square because it's 3 times 3. Looky here, 2x times 2x, 3 times 3, a plus and a minus, we have a pattern. So here's my question to you. If I told you to do 9x squared minus 25, I want you to factor that. Do you have to have a box? No, because this is the difference, which means subtraction, by the way. That's the answer to a subtraction problem, of two squares. This is a perfect square, and so is 25. So let's think about what multiplies to give me 9x squared. I need the same number times itself. It's 3x times 3x. Test it out for yourself. And what multiplies to give me 25? What's my square root? 5 times 5. They have to be the same number, folks. These have to be the same. And then remember what pattern we had with the pluses and minuses? I need one plus and one to be minus. And then we're good to go. Look, I did that without x's and boxes. And that is what I want you to be able to do. I want you to be able to find all your perfect squares and to know what they look like, and I want you to be able to factor these without a box. Now, if you have to use a box, we're not going to panic about it, but it would really help you a lot if you could just look at it and go, oh, that's a perfect square, and so is that, and it's a difference. I know this pattern. Let me write the pattern out in a nice mathy way. I'm going to call it a squared minus b squared, a perfect square minus a perfect square. Can you guess what would be in my factors? Well, what multiplies to be a squared? A times a. What multiplies to be b squared? B times b. Get your plus and minus in there and you're good to go. So this is the pattern. This is difference of squares, and this is the pattern that they will all have. Now, not everybody remembers their perfect squares. I'm going to go ahead and list them here. If you need more practice with this, I'm going to give you a Quizlet that will have all the perfect squares in there that you can just practice, okay? So, let's just do that real quick. I want to list them out, and that might be all you need. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. 11 squared is 121. 12 squared is 144. Now, if you have been using your calculator a lot in the last few years, you may have forgotten this list. But these are perfect squares. What that means is, if I took the square root of 36, it would give me 6. Okay, those are perfect squares. There's a couple others that are kind of handy to know. 15 squared is 225, and 20 squared is 400. Those are just kind of handy to have in your back pocket, but there are some others that are kind of nice in there too. So anyway, I have put a Quizlet together for practicing the perfect squares, and I also have another Quizlet that will help you practice factoring difference of squares. I would highly suggest that you go ahead and just try those Quizlets. You may or may not need this. It depends on how well you remember those. But this one with the difference of squares, you should do a lot of practicing with that. It really just takes a little practice remembering how to do it, especially when you have numbers on both of the terms. Okay? Try them out. They're not required. You're not getting a grade for them, but it will help you tremendously when we get to the next step. All right. Enjoy, guys.